The safety board is charged with investigating accidents in the aviation industry, and all too often we identify things that go wrong. Firefighters are charged with really kind of stepping in when an emergency is already underway and really having cool heads, making the right decisions, stepping in to save other people. When we, in our investigations, find that there are deficiencies, it's not necessarily because people have done something wrong, but maybe because they need better training or better equipment or better procedures or better communication.
The fastest and safest way to gain access to any aircraft is through the normal entry points. Passenger doors, overwing exits, cockpit escape windows, and rear stairs, when equipped, should all be attempted before any attempts at forcible entry. In rare incidents, the intact fuselage may remain pressurized. When approaching the aircraft, check for an open aft belly fuselage outflow or pressure control valve. If it is open, the hull should have internal ambient pressures. Opening a door under pressure may cause injury to the responder. Attempts to open damaged doors may allow faster access than forcible entry techniques involving cutting out sections of the fuselage, especially for small planes without plug-type doors. However, trying to pry open plug-type doors and hatches is not likely to be worth the effort. Highly reinforced frames and perimeters make it nearly impossible to create an opening large enough to insert the tips of a hydraulic spreader. Plug-type doors and hatches can't be opened when the aircraft is pressurized, but vault doors can be opened under pressure. This can be extremely dangerous for ARFF personnel. Some doors have indicator lights that turn red when the aircraft is pressurized and white when it is not. If normal entry points are inaccessible, forcible entry through the fuselage may be the best option. As you develop your standard operating procedures for aircraft forcible entry, make sure you partner with the airlines with service to your airport. They can serve as a great source for information and resources.
At the Airline Pilots Association, we believe that a well-trained, well-prepared pilot is the best safety device in the cockpit. And when an emergency occurs, you can bet that we're going to get that aircraft on the ground as quickly and as safely as possible. It's then the firefighters' turn and the first responders' turn to become the real heroes and evacuate the passengers, protect the crew, and protect the aircraft.
This video is a general introduction to aircraft forcible entry techniques and tools. It also covers relevant aspects of aircraft construction. As with any aspect of ARFF operations, consistent training is key to ensuring that you apply your knowledge of forcible entry in an actual incident.
These are highly specialized vehicles, and to force entry into an aircraft is very, very specialized. It takes special tools, talent, it takes a lot of training. The firefighters need to know what aircraft are at their airport, who comes and who goes, what military installation is nearby, who could be transient, who could be diverted to your airport. Knowing the airframes, knowing aircraft familiarization is going to play a major role.
Understanding aircraft construction is a crucial part of the ARFF firefighter's responsibility. The load-bearing structure of a large passenger or cargo aircraft is composed of strong beams called stringers that run the length of the aircraft, as well as frames that circle those beams. An open area between stringers and frames is commonly called a bay. Bays are typically 18 to 20 inches long and 8 to 10 inches wide. You can identify bays from outside an aircraft by noting the lack of fasteners on the skin. Fuel can be found in several locations on any given aircraft, including in the wings, the vertical and horizontal stabilizers, and the fuselage. Wiring, tubing, controls, and other components of the aircraft's many systems are threaded throughout the main structure. An aircraft's outer skin is riveted to both stringers and frames, and mounted components such as engines and windows are attached. Aircraft windows are typically constructed of 3 layers of approximately ½ inch plexiglass. The outer 2 panes are held together by a rubber seal secured to the window frame by metal clips. Pressurization of the aircraft cabin plays a significant role in keeping the window in place while in flight. Plastic panels used in the interior finish hold the 3rd pane in place. Modern aircraft contain a wide variety of materials, including aluminum, aluminum alloys, steel, titanium, wood, and plastic. Aircraft manufacturers are also incorporating more composite materials and metal alloys as they provide increased strength with less weight. It is difficult to visually identify different materials on a painted aircraft, but you should be familiar with the properties of the most common materials. Aluminum and aluminum alloys are common. With the proper tools and techniques, aluminum can be fairly easy to cut. Steel is used in areas where strength and heat tolerance are required, such as landing gear and engines. Cutting through steel is slow, creates a great deal of heat and sparks, and will quickly dull your cutting tools. Cerametallic aluminum alloy has replaced magnesium in most commercial and military aircraft for components in the wheel and brake assemblies. Titanium is often used to reinforce and protect skin surfaces. It is also used in turbine blades, auxiliary power unit enclosures, and landing gear. In newer aircraft, titanium may be found in forcible entry areas. Titanium is much more difficult to cut than aluminum.
With the new aircraft, with all their composites, the landmarks that we used to rely on, such as rivet lines, they're no longer existent. So we need to do pre-planning and have SOGs on where we're going to cut these aircraft.
Many modern aircraft incorporate advanced composite and aerospace materials, such as Kevlar, boron epoxy, and radar absorbent material. Burning composite materials release toxic gases. Even cutting through composites will produce airborne composite fibers that can be hazards. Composite material fibers may not be visible to the eye, but they can carry toxic byproducts into the lungs or under the skin. Airborne fibers are also highly conductive and can seriously damage electrical equipment. If composites are involved in a post-crash fire or forcible entry cutting operations, exposure of personnel and valuable equipment to airborne composite material should be minimized. Methods can include application of aspirated foam, fine water spray, or water-based suppressants, such as floor wax mixtures, through a pump pressure type hand sprayer. Notify tenants with aircraft and buildings downwind that composite fibers may be in the atmosphere. Consider securing building ventilation systems downwind that may draw composite fibers into the building. Finally, restrict helicopter activity overhead that may agitate the fibers by downdraft. All personnel involved in firefighting or forcible entry operations must be fully protected with personal protective equipment, including SCBA. Tubular steel can be found throughout many aircraft. It is much easier to cut than structural steel, but it still produces sparks when cut. ARFF personnel should know the differences among these materials and their typical locations on aircraft when planning forcible entry. They must also understand the hazards of aircraft fuel, hydraulic, electrical, flight control, and escape systems when planning forcible entry. Rescue charts from airlines and aircraft manufacturers provide a great deal of helpful detail. The ARFF Working Group's ARFF database also puts a great deal of this information on a mobile data terminal or laptop.
I have a lot of respect for the firefighters for aircraft because of all the things they have to know. Having to know the different types of airplanes that come into your airport and knowing how they're structured, the tools you have to learn how to use. It's almost mind-boggling to think that these people can even learn all this stuff and be able to apply it when it needs to be applied.
A typical fire department will have a wide variety of tools for aircraft rescue and entry. Common hand tools, such as wrenches, pliers, hammers, chisels, and saws, can help with simple tasks like removing access panels and opening flush-mounted handles. Flathead, pick-headed, and crash axes can be used to punch holes in the aircraft's skin. Pike poles come in a variety of lengths and styles. They can be used to reach, push, and pull. Seatbelt cutters, linoleum cutters, and razor knives can cut webbing, cargo nets, and seatbelts. Wire, bolt, and cable cutters are effective for cutting small tubing, hoses, and cables. Prying tools such as pry bars, Halligan tools, wrecking bars, and crowbars have a variety of uses. They can effectively force open doors and hatches on light, non-pressurized aircraft. Power tools are classified by their power source. Electric saws, drills, screwdrivers, and other tools can save firefighters considerable effort over manual tools. Use caution with electrical tools not rated for use around flammable or explosive vapors. Battery-operated rechargeable tools provide a great deal of power without fumes, hydraulic lines to be caught or entangled, or excessive noise, which can contribute to the anxiety of trapped occupants. Hydraulic spreading and cutting tools can spread, pull, bend, and cut aircraft structural members. Power spreaders, cutters, and rams are most effectively used inside the aircraft to remove seats and obstructions. Hydraulic tools can be powered by hand pumps or power units. Power units are designed to keep the unit's noise, heat, and possible ignition sources outside the fuselage. Pneumatic tools use pressurized air from compressors, breathing air bottles, or a vehicle-mounted air supply system. The air chisel cuts by striking a surface thousands of times per minute. A variety of cutting tips are available. The air chisel is fairly lightweight and easy to hold and control, making it possible to use from a ladder. Pneumatic piercing tools are also available. Reciprocating saws are available in AC and battery-powered models. Reciprocating saws are small and light enough to be used while reaching overhead or standing on a ladder. Although a reciprocating saw with the right blade will eventually cut through most materials on an aircraft, it is extremely slow and tedious. Make sure you have a good supply of replacement blades.
What I consider probably our best option when it comes to forcible entry is to use a 16-inch rotary saw. And what we try to do is have an opening of about 4 by 3 to where we can get in with our equipment, included our full PPEs, and assist with evacuation of the passengers if needed.
The most effective forcible entry tool is a rotary saw. With the right blade and a good technique, rotary saws make the fastest and cleanest cuts in fuselage and other tough areas. There are many types of rotary blades with different strengths and weaknesses. Composite blades are inexpensive and will cut through most aircraft fuselage components. They tend to create a great deal of sparks when cutting through structural components. Composite blades will also shrink as they are used. The best composite blades for aircraft forcible entry are actually blades designed for masonry. They shrink less than blades designed for metal and perform quite well. Read the manufacturer's cautions regarding use and storage. The integrity of some composite blades is affected by age and storage in areas with fuels and lubricants. Diamond cutting blades are also very effective, especially for new composite materials. Diamond tip blades are significantly more expensive than composite blades, but typically have a longer life and do not shrink and are not affected by fuel vapors. Blades for rotary rescue saws are available in 12-inch, 14-inch, and 16-inch diameters. A 12-inch blade is not large enough to cut all the way through skin, structural members, and interior finish of large frame aircraft. A 12-inch saw would be adequate for GA aircraft and some commuter aircraft, and the smaller saw is much lighter than a saw that can handle a 16-inch blade. A 14-inch blade will usually cut through all components, but just barely. In some large frame aircraft, a 14-inch blade will not cut through interior finishes or some structural members, which complicates entry. A 14-inch composite blade may start out large enough, but fail to penetrate toward the end of a long cut due to blade shrinkage. A 16-inch blade is large enough to cut through all components of the fuselage and interior finishes on the largest aircraft. However, these blades require a larger, more powerful saw. A 16-inch rescue saw is more difficult to operate due to the weight, particularly above chest height.
When we start talking about forcible entry and our training that goes along with forcible entry, typically the first thing we talk about are doors and knowing how to open up doors and then go on to other emergency exits using the means that the aircraft already has if they're available to be opened. If that's not going to be acceptable and we need to now cut the aircraft, there's a couple of different trains of thought.
The decision to proceed with forcible entry should only be made if emergency entry is absolutely necessary and all normal means of gaining entry have been unsuccessful. Whenever possible, airline representatives should be involved in the development of a forcible entry incident action plan. During any aircraft incident or accident, aircraft in the area inside and immediately surrounding it are considered the hot zone. All personnel operating in the hot zone are required to be fully protected with SCBA and PPE. Anytime a fuel spill is involved, the fuel must be covered with ARFF foam to prevent flammable vapors from being released or finding an ignition source. The integrity of the foam blanket must be maintained by reapplying foam. If operations require ARFF personnel to work under or upon the aircraft, some level of stabilization is required. In very basic precautionary scenarios, it may be sufficient to receive approval from the captain to walk under his aircraft or the placement of chalk blocks or gear pins. If the operation will include forcible entry operations, more stabilization may be required. Keep in mind that an uncontrolled or hard landing could cause the aircraft's load to shift or cause the landing gear to fail. Aircraft that leave hard surfaces or have a failure of one or more sets of landing gear may be in positions that will stress and weaken the airframe. An aircraft fuselage without wings or a tail is very unstable. Before attempting forcible entry, the aircraft must be stabilized. This situation may be present after an accident or with a fuselage section provided for training opportunities. Movement of the wreckage or fuselage can further injure trapped victims and rescuers. Saws and other tools can create large amounts of noise and sparks. Rescuers and occupants should be warned of and protected against these hazards during tool operation. If fuels or fumes are present in the hot zone, or if power tools are being used on or around the aircraft, a charged manned foam handline must be established for protection. Some saws are equipped with a water inlet to keep the work cool.
So knowing where to cut, how to cut, set it up so that you're taking the least amount of steps, the least amount of time with the saw, and it'll help you out in the long run just in fatigue factor.
Choosing the most efficient plan to cut an entry point and remove interior components requires a combination of skills, tools, techniques, and teamwork. The recommended location for the horizontal cuts in a forcible entry opening is the area from the top of the cabin windows, between the horizontal rivet lines, to approximately 6 inches above the passenger deck. Avoid cutting at or directly below the passenger deck, as this area is one of the most rugged areas on the aircraft and also carries system piping and wiring harnesses. Avoid cutting around aircraft doors. There is substantial structural reinforcement in these areas, which will be too difficult and time-consuming to be of benefit. The rivet pattern on an aircraft skin indicates the location of underlying structural members. Sanding exterior paint can help expose hidden rivet patterns. Look at the rivet patterns and mark the location of structural members with spray paint or wide felt tip markers. These are the areas to avoid during cutting operations. Using a different color of marker or paint, mark the location of 4 cuts that will form your intended square or rectangular opening. The utility of these guidelines will become immediately apparent when trying to cut a straight line with a heavy rescue saw under very difficult circumstances. It is highly recommended that you keep 2 different colors of high visibility spray paints in your forcible entry toolkit. On passenger aircraft or freighters converted from passenger aircraft, there is a rivet line above the windows associated with the mounting of the window box. There is another rivet line above that associated with the mounting of the cabin ceiling and overhead storage bins. The area between those rivet lines is the best place to make your top horizontal cut. Cargo aircraft that were manufactured as freighters will not have windows to use as a reference. Make the horizontal cut in nearly the same location as on the passenger aircraft using the same rivet lines for guidance. With the increased use of composite materials, identifying where panels attach to structural members is more difficult. Rivet lines will not be present. When cutting composite materials, full PPE, including SCBA, should be worn.
One of them that we found has worked real well in our training is to take an area of the aircraft, break out 3 windows, and use that window frame to now make about a 4x3 opening.
Windows can be popped in easily by a couple of methods. Striking the center of the window with a sledgehammer breaks the clips and knocks the windows fairly easily into the interior. The H-ret can be used very effectively to knock in windows as well. Simply put the penetrating tip against the window exterior and extend the tip forward slowly. When using H-rets that fire their penetrating tip to pierce an aircraft, do not use the firing function to remove windows. The power and speed of the piercing tip will pierce rather than remove the window. Advance the tip slowly forward to efficiently remove the window. Using either method, begin by knocking out 3 to 4 windows in a row. Removing windows allows firefighters to look inside the aircraft and provides handholds for removing the piece after the cut is complete. Now, we have the windows removed and the guidelines painted on the aircraft. The first method of cutting shown here is the fastest and most effective method. Using a rotary rescue saw with a 16-inch diamond cutting blade or a 16-inch composite masonry blade, make the first cut at the bottom of the marked opening, approximately 6 to 12 inches above the main deck. Making this cut last will leave the weight of the section hanging down, which will cause the saw to bind up during the lower cut. Cut downward from the center of the 2 outside window openings. Continue the cut downward through the horizontal cut on the bottom. Cutting from top to bottom allows us to use the weight of the saw to our advantage. Make sure that all cut lines cross so that additional cuts are not required to remove the section. The final cut is the top horizontal cut, along the line you painted in the area between the rivet lines. The horizontal cuts are the most difficult. Make sure the blade remains buried at full depth in the fuselage and stays there throughout the full cut. The blade will want to ride up and over structural members. The weight of the saw creates a tendency for it to dip down. The guidelines will indicate whether you are slanting away from your line, perhaps into heavily reinforced areas. For saws with adjustable RPM, maintain high RPM throughout the cut. Cutting through structural members will tend to reduce saw speed. If the saw speed slows down due to resistance, back off the pressure. Allow the RPMs to go back up and push forward. Aluminum can foul even diamond blades. Clean a fouled blade by cutting for a minute or so on a concrete block, brick, asphalt, or steel. However, runway, taxiway, and ramp concrete are usually too hard and will wear out a blade instead of cleaning it. It is always a good idea to have several spare blades on hand so a fouled or damaged blade does not end the operation. Window openings can be used as handholds to remove the fuselage section. A properly trained and equipped crew can make an opening like this in about 12 minutes.
What we're recommending at this point, and what we like to see, is a 16-inch rotary saw. Not everybody's going to have one. If you have a 14-inch saw, you have to compromise. You have to change some of your tactics.
If the blades being used are not large enough to cut all the way through the components of the fuselage, or if the cut lines do not cross, it may be necessary to use a reciprocating saw or hydraulic cutter to cut away any remaining pieces that are preventing the piece from being removed. Before making entry, place a salvage cover over the lower edge to protect people and equipment from the sharp metal. Although this method is the fastest and most efficient, it is not the only method available. The next method shown makes use of hand tools and hydraulic rescue tools. It is more labor-intensive, takes more time, and leaves sharp, jagged metal, but it works. The initial steps to identify the rivet lines, mark the fuselage, and remove the windows are the same. Next, using the pointed end of a pig-headed axe or a halligan and a maul, make a hole in every area between a structural member along the marks you made to guide your cuts. The holes must be large enough to fully insert the tips of your spreader attachment. When using hand tools to cut skin, make the initial strike immediately adjacent to a structural member to minimize bounce, movement of the aircraft piece, and the effect on occupants. Insert the tips of a spreader into each hole and spread as far as you can in the direction of the cut markings, ripping the metal as you go. If your spreader does not rip the aircraft's vertical members, insert a cutting tool and slice the exposed structural members. Additional spreading may be needed to separate the fuselage from interior finish or other connected wreckage. A team of 2 spreaders and 1 cutter is more efficient than individuals working separately. When the cuts are complete, remove the section. Be prepared to remove dangerous pieces and protect sharp areas with mats or salvage covers. An air chisel can be used to remove any particularly hazardous sharp pieces. The cockpit is one of those areas of the aircraft with the heaviest structural reinforcement. The best access points into the cockpit are through escape hatches or operable windows or from the aircraft cabin. Forcible entry by other means into the flight deck will be extremely difficult. The cockpit windows are the strongest, thickest windows on the aircraft. Large frame aircraft windshields are more than an inch thick and constructed of plexiglass sandwiched between layers of glass. Axes and sledgehammers will only cause shallow fractures in a 727 windshield. If it is absolutely necessary to get through an aircraft windshield, a diamond cutting blade can be used to cut out a section. Cutting through plexiglass windows will slow down and gum up a composite blade.
A gentleman that was well known throughout the firefighting industry for being a forcible entry expert, Lane Kemper, not only taught that forcible entry was important, but making sure we have a safe way to get out of that structure or aircraft is also, if not equally important, maybe more important. So we always want to make sure we not only can get onto the aircraft, but we have plenty of openings to get off of the aircraft as well.
During an aircraft accident, it is quite common for seats, overhead compartments, interior finish, and galley and lavatory equipment to break loose. Interior entanglements can be quickly and effectively handled with hand tools or electric or hydraulic cutters and spreaders. Removal of aircraft seats may be necessary to gain access to a trapped occupant. The seat bases can be easily cut using rescue cutters. A two-member team can remove sections of seats very quickly. A reciprocating saw can also be used, but this is a much slower method. The remaining seat mounts left in the track after removing the seat can be knocked out with a sledgehammer or flathead axe. Removing these pieces eliminates snag points and tripping hazards for rescuers and equipment. Only remove obstructions that are necessary to accomplish your mission. Accident investigators will study the placement, condition, and position of every piece of the aircraft. It may be necessary to cut wiring, cables, or tubing, which could still be pressurized or energized. Firefighters should know aircraft tubing color codes, pressures, and the status of power on the aircraft. Tubing sizes range from 1/4 inch, commonly used for hydraulic and pneumatic lines, to 4-inch or larger for heating, ventilation, and air conditioning. Hand cutters are fairly effective in cutting tubing up to 1 inch in diameter. Power cutters are more useful for larger tubing. Metal tubing can be made of aluminum or stainless steel. Steel piping is more difficult to cut and may spark. A magnet can be used to determine if the tube is steel or aluminum. Any tubing that must be cut should also be crimped to prevent leaks that could cause additional hazards. Wiring harnesses and control cables can create an obstructive web. Individual wires and cables can usually be cut easily with hand cutters. Large wiring bundles are common and can be cut with rescue cutters. Large stainless steel aircraft control cables will require long-handled cutters with hardened steel jaws. Rescue saws or reciprocating saws are also effective. FAA Advisory Circular 150/5200-12, First Responders' Responsibility in Protecting Evidence at the Scene of an Aircraft Accident or Incident, provides guidance your department can use to develop standard operating procedures to help preserve the scene for investigators.
Sometimes people have to work on the fly to figure out how to address situations. But really what this goes back to is your training, making sure that you have good trainings that will prepare you what you might face in real life.
When I travel personally, and I take my family with me as well, I expect a well-trained, well-prepared cockpit crew, in-flight crew, ground crew, and mechanic crew to take care of that aircraft. In an emergency mishap, I don't expect any different. I expect the aircraft rescue and firefighting crews to be well-trained, well-prepared, and ready for any emergency that they may encounter.
The best way to train and develop proficiency in the use of forcible entry tools, equipment, and techniques is to train on actual aircraft. If you are lucky enough to have a fuselage or fuselage section to use for training, make sure an airline representative is available for consultation during the exercise. Even without an aircraft that you can cut into, a great deal can be done to prepare. Make sure you have the tools and resources available at your airport or through mutual aid. Include mutual aid departments in your planning and training. Conduct training visits to aircraft to inspect the skin, identify rivet lines, and identifying platforms to work on during forcible entry operations. Establish a department standard operating procedure with a plan that gets the job done at your airport. Planning, preparation, and training are the keys to success.
One of the things that we always hold dear is the quality of training that crew members get, that our maintenance gets, and the fact that we know that if we have an incident and need to utilize the services of ARFF at an airport, they're as professional and trained as well as we are in the airplanes. That's a darn good feeling to know that.
You never know when you're going to be called on. And when you're called on, there are people whose lives are depending on you responding appropriately.